This line introduces the quiz question about using FeatureUnion in a scikit-learn pipeline. It sets the stage for evaluating the given statements related to its functionality. Let's dive in. This line presents the core question of the quiz. We will need to analyze each statement, A, B, C, and D, based on our understanding of FeatureUnion in scikit-learn to determine which are true. This is where we'll put our knowledge to the test. Statement attests whether we know that FeatureUnion can handle different types of features, like numerical and categorical data, with separate pre-processing steps. Think of it like having specialized tools for different parts of a project. Statement B checks our understanding of how FeatureUnion combines the results of multiple pre-processing steps. It's like merging different data columns into a single, broader dataset. Statement C explores a potential misconception about FeatureUnion. It questions whether all pre-processing steps need to produce outputs of the same size, which isn't true. FeatureUnion handles varied sizes gracefully. It's like merging different sized puzzle pieces. FeatureUnion takes care of aligning them. Statement D probes a common assumption. Does using FeatureUnion always lead to better results? The answer, as we'll discover, is no. It's a tool, not a magic bullet for performance gains. Using the right tools for the job matters more. This line indicates an example dataset will be shown to illustrate the concept. This is a helpful context clue to understand how the features are structured for the problem. This line shows a snippet of the sample dataset, highlighting the different feature types, numerical like customer age, and categorical like subscription type. Understanding this will help to analyze how FeatureUnion could help process these different features. The problem involves a machine learning model to predict customer churn. This dataset contains both numerical and categorical data that needs to be pre-processed before it can be used to train the model. These are quantitative customer characteristics like age and the length of their subscription, tenure. Think of them as numbers we can directly use in calculations. These are qualitative features that describe customer characteristics using categories or labels, like subscription type, basic, premium, and country of residence. These can't be directly used in calculations, so we need to convert them into a numerical form. This is a scikit-learn tool used in machine learning pipelines. It combines different pre-processing steps for numerical and categorical data. It's like a chef combining different ingredients to create a delicious dish. This is a pre-processing step specifically for numerical features. For instance, standard scalar transforms numerical features to have zero mean and unit variance. This is done to improve model performance. This is a pre-processing step for categorical data. One hot encoder converts categorical features into numerical vectors. This converts categories like basic and premium into numerical representations that the machine learning model can understand. After applying the transformers, FeatureUnion combines the pre-processed numerical and categorical features. These combined features are ready for the next step. This is a machine learning algorithm used to predict customer churn based on the pre-processed features. Logistic regression is a common choice for classification tasks like this one. The goal of this entire process is to accurately predict which customers are likely to churn, cancel their subscription. By using FeatureUnion to pre-process the data properly, we can create a better prediction model. This statement is false. Remember, FeatureUnion is all about combining different pre-processing steps. Each step might change the data in a unique way, leading to different output sizes. It doesn't force them to be the same. Instead, it cleverly joins these differently sized outputs together. Think of it like combining ingredients in a recipe. Some ingredients are larger, more data points. Some are smaller. The recipe doesn't require everything to be the same size before mixing. It simply combines them. This is also false. Using FeatureUnion isn't a magic bullet for better results. Its effectiveness depends entirely on whether the separate pre-processing steps are actually helpful for your specific data and model. Sometimes a single, well-chosen transformer is perfectly adequate. It's like choosing tools for a job. Sometimes a hammer is enough. while other times you need a whole toolbox. FeatureUnion provides more tools, but doesn't guarantee a better outcome. This statement is true. That's the beauty of FeatureUnion. It's designed to handle different types of data, like numerical and categorical features, with their own specific cleaning methods. Think of your data as a mix of apples and oranges. You wouldn't peel them both the same way, right? FeatureUnion lets you peel the apples and prepare the oranges separately before combining them into a delicious fruit salad, your final processed dataset. This is also true. Once FeatureUnion has finished its pre-processing tasks, it neatly joins the results side by side, adding new columns to your data. It's like merging two spreadsheets. The outputs of each preprocessor become new columns in the combined spreadsheet. This is the main topic of the quiz. FeatureUnion, in the SCIKITLEARN library, is a powerful tool that allows you to perform separate pre-processing steps on different parts of your data and then combine the results. This refers to the core component in scikit-learn that combines multiple data transformations into one. Think of it as an assembly line where different workers, transformers, handle different parts of the job, pre-processing different features, before the final product, processed data, is ready. It's super helpful when you have a mix of numerical and categorical features, requiring different treatments. These are features represented by numbers, like customer age and how long they've been a customer, tenure. They might need scaling or normalization before being used in a machine learning model. Imagine needing to adjust the scales of a map to align with another. That is like how data needs adjustments to be in harmony. These features represent categories or groups, such as the customer's subscription plan, basic, premium, or their country. They often need to be transformed into numerical representations, for example through one-hot encoding, before they can be used in most machine learning algorithms. Think of a recipe, for example, how you may need to categorize your ingredients for the recipe before you can cook it. A scaler is a pre-processing step for numerical features. It transforms the numerical data to have a specific range or distribution, making it easier for the model to learn patterns. Standard scaler, for example, centers the data around 0 and scales it to have a standard deviation of 1. It's like bringing a group of people, some giants and some smaller, to the same average height. This is a pre-processing step for categorical features. It converts categorical values into multiple binary, 0 or 1, features. For instance, country could be encoded into separate features for each country. US equals 1, UK equals 0, Canada equals 0, etc. Imagine you are creating codes to represent colors, then assign a 0 or a 1 to each color for each ingredient. This is the scikit-learn class, used to combine multiple transformers. It applies different transformers to different feature subsets, like applying a scaler to numerical features and a one-hot encoder to categorical features, and then concatenates their outputs. Think of it as a big organizer that takes care of handling all different pre-processing actions. After FeatureUnion processes the data, the outputs from different transformers are joined together into a single feature set. This new, combined feature set is ready for the next stage, model training. It's the final ingredient combination after mixing different ones. This is the machine learning model used to predict customer churn. The classifier takes the pre-processed data from FeatureUnion as input and learns to predict whether a customer will churn or not. Logistic regression is one example. Many others exist. This is like the final recipe that takes into account all ingredients and preparations. The final output of the whole process, the model's prediction about whether a customer is likely to churn or not. It's what you were aiming to get all along. The dataset contains information about customers, including numerical data like their age and how long they've been subscribed, tenure, and categorical data such as their subscription type and their country of origin. This data will be used to build a model that predicts whether a customer will stop using the service, customer churn. It's a great dataset to work with. These are features represented by numbers. Age represents the customer's age, and tenure represents the duration of their subscription in a relevant unit like months or years. These are likely to be preprocessed using methods such as standardization or normalization. These are features representing categories or groups. Subscription might include categories like basic, premium, etc., while country would list the different countries where customers are located. These features typically need to be converted into numerical representations, often using techniques like one-hot encoding, before they can be used in a machine learning model. This is a pre-processing step, specifically for numerical data. Standardscaler is a common choice for numerical features, as it transforms the data to have zero mean and unit variance. This helps improve the performance of some machine learning algorithms. Isn't that cool? This is another pre-processing step, but this time for categorical data. ONEHOTENCODER converts categorical features into a numerical representation using binary vectors, one for each category. This allows machine learning algorithms to use these features effectively. This is a crucial step for handling categorical data. This refers to the output of transformer1. After applying the preprocessing to the numerical features, age and tenure, you'll have a transformed version ready for model training. This refers to the output of transformer2. Following the application of the one-hot encoding or similar technique, the categorical features, subscription and country, will be in a numerical format that's suitable for model training. This is a scikit-learn component that takes the outputs from multiple transformers and combines them. In this case, FeatureUnion merges the transformed numerical and transformed categorical features into a single dataset, ready for the classifier. It's like a magical merging machine. This is the result of FeatureUnion. The transformed numerical and categorical features are combined column-wise, meaning new columns are added, to create one complete feature matrix. This is the machine learning model that will use the combined and transformed features to predict customer churn. Examples include logistic regression, support vector machines, SVMs, or decision trees. This model will learn patterns from the data to predict whether a customer is likely to churn or not. Pretty neat, huh? The final goal of this machine learning project is to accurately predict whether customers will churn, stop using the service. The performance of this prediction will be evaluated using appropriate metrics like accuracy, precision, and recall. These are features represented by numbers. Age represents the customer's age, and tenure represents the duration of their subscription in a relevant unit like months or years. These are likely to be preprocessed using methods such as standardization or normalization.